Okay, welcome back to Mr. Hassan's Maths channel. I'm now going to be answering this question, which is question number 2 from the Mechanics M1 International A-Level Edexcel January 2017 exam. And one of the viewers on the channel has requested me to answer. He's asking about part B, but I'll start with part A. A particle P of mass 0.5 kilograms moves under the action of a single constant force 2I plus 3J newtons. Find the acceleration of P. So we know that the resultant force is equal to the mass times the acceleration. Right, that's the formula that we know. That's very important for us to be able to apply. So in this case, we were given the mass is 0.5 kilograms, so half a kilogram. And we're given the force, which is 2I plus 3J. I like to write show my working as column vectors, and then in the end write the answer in the form required. So here we can just replace F with 2, 3. And we can replace mass with a half. And acceleration is what we have to find A. So we can just rearrange this, basically multiply both sides by 2. So you have A is equal to 2 times 2, 3. So the acceleration, which is a vector, is 4, 6. And there's the answer for part A. Very simple. Okay, there's part A. Now the viewer said, for part B, I found the magnitude of the acceleration. And it didn't give me the correct answer. And the reason is, the question is not asking you to find the magnitude of the acceleration. The magnitude of the acceleration is not the speed. We have to first find the velocity. So it says at time t seconds, P has velocity v meters per second. When time equals 0, the velocity is 4I. Find the speed of P when t is 3 seconds. So basically, we can use suvat here because we have a constant acceleration. So we'll just write down what we know from suvat. Now, we don't know what S is. Now, the initial speed, as they told us, when time equals 0, v is 4I. That's what the initial speed is when time is 0. Well, as a column vector, that would be 4, 0, 4I plus 0j. And the speed, the final velocity, is going to be v. That's the velocity, not the speed, the velocity. But we need this to find the speed. So that's the initial velocity, the final velocity. The acceleration is what we found in part A, which is 4, 6. And the time is 3 seconds. So we've got to find the velocity at 3 seconds, or the speed at 3 seconds. First, we need to find the velocity. So here we're going to use u, v, a, and t. So we know that v equals u plus at. So what we're looking for, v, is equal to u, which is 4, 0, plus the acceleration, which is 4, 6 times 3. So it's 3 times 4, 6. So that gives us v equals, that's 4 plus 12, which is 16, and 0 plus 18. So that's 16, 18. So that's the velocity. All right. So we know the speed is the magnitude of the velocity. So we got to find the magnitude of this, which is 16 squared plus 18 squared, which will give us our answer. So we have the square root of 16 squared plus 18 squared, which gives us 2 root 145, which we can round to 3SF, gives us 24.1 meters per second. That's the speed. The speed is the magnitude of the velocity, not the magnitude of the acceleration. Okay, so I'm guessing what the student did was found the magnitude of the acceleration and thought that's velocity. No, the magnitude of the acceleration is not the velocity. The speed is not the magnitude of the velocity of the acceleration. The speed is the magnitude of the velocity. And by the way, it's probably better to write the answer for this part A as 4I plus 6j, although both will be acceptable because they gave the question in terms of I and j. So it's better to write it in that same format, but there's no problem if you don't, and that's in meters per second squared. All right, so there's acceleration, and there's the speed. The speed, you have to find the velocity using v equals u plus at first, and then Find the magnitude of that velocity to give you the speed. Now for part C, it says, given that P is moving parallel to the vector 2i plus j at the time t equals t, find the value of t. So again, we're going to use v equals u plus at. Let me just put these values down. Now we want to find, we know that the velocity at the time t is parallel to this vector. So it's going to be some constant times 2, 1. Okay, because at time t equals t, it's moving parallel to this vector 2, 1. So it's going to be some multiple of that vector, right? The initial speed is what we found originally, which is 4.0, which they told us already in the question. And the acceleration is 4.6, which we found in part 1, the constant acceleration. So we can set up using v equals u plus at equations here. So v equals k times 2, 1. U is equal to 4.0. And you've got t times a, which is 4.6. So from here, I can set up a pair of equations. I can look at the I components, and I can set up an equation 2k equals 4 plus 4 times t. And I can look at the j components, and I can set up an equation 1 equals 0 plus 6t. Sorry, k equals 0 plus 6t. So this is 6t. So k equals 6 times t. So I can solve these equations simultaneously to find what t is. So I can replace this k here with 6t. So I can say 2 times 6t is equal to 4 plus 4t. That's 12t is equal to 4 plus 4t. And then we can just basically subtract 4t from those sides. That's 12t minus 40, which is 8t equals 4. Therefore, I can say t is equal to 4 over 8. So t is equal to a half. And this is in seconds, so it's half a second. Okay, so there's the answer to part C, and that concludes this question. Right, so this question is all about basically, vectors, force equals mass times acceleration, understanding that the magnitude of the velocity gives you the speed. Okay, and the last part here, understanding that when two vectors are parallel, they are multiples of each other. Okay, so there's the answer to this question. Question number 2 from this January 2017 International A-Level Mechanics M1 paper. Other questions from this particular paper can be found in the playlist that will appear in this region here. Other questions from this topic of vectors can be found in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.